Hey, just a quick video to explain about how to use great circles to measure distances. So, what a great circle is it's any circle that's drawn on the Earth that goes all the way around the Earth and divides the Earth into two equal hemispheres. And the great circle can be drawn a great circle can be drawn between any 2 points on the Earth's surface because you can always connect them with a direct line and continue on and go all the way around the Earth and divide it into two equal halves. And so the shortest distance between any 2 points on the Earth is along a great circle. And along a great circle, 1 degree, since great circles are circles, they are measured in degrees, right? Distances are measured in degrees. 1 degree is equal to 69 miles or 111 kilometers. But a lot of times we like to measure things in degrees. So you can use a number of different things. You could use a globe and a piece of string. Or in this case, Google Earth Pro is pretty good. So what you can do is just zoom in on whatever your location is, right? So in our case, we're looking for Rochester, right? And use the little ruler tool here, and we're just going to click on that and then zoom out and find whatever it is you're trying to measure to. And in this case, let's say it's right there. And you just click on that, and we can see that's 13.54 degrees. Easy peasy. So you can use this tool to measure between any 2 points on the Earth's surface using Google Earth or Google Earth Pro. Now, there's a couple of other options, though. For seismologists, a lot of the things that we need to do are actually measuring distances to earthquakes. And you could put in the latitude and longitude of the earthquake on Google Earth and use that as a starting point to measure the great circle distance. But here's another kind of clever way to do it. So let's say this is the Iris Earthquake browser. Let's say we wanted to measure the distance to a particular earthquake here. We could, once we have it on the screen here, we could click on other formats, and then we can find that particular earthquake. Let's say it's this one right here. And where it says Iris ID, if we click on that, it brings up a page with lots of cool information and stuff that you should have a look at. But this one right here, this Wilbur 3, brings up a nice screen here. And what it has then is a little slider here where you can measure the distance. And you can see that there's some small circles that are centered on the epicenter of the earthquake. And the idea here is you can just zoom in to our CTC. Let's keep going here. And then adjust the distance range here until, whoops, there it goes. It's right through there. So here's this line coming through. So I can see that the distance is going to be close to 48. But it's a little short, so let's say 48.4. Too big. 48.2. Good. 0.23 is pretty good. So 48.23 would be the distance to that particular earthquake right there. And so this Wilbur 3 is a pretty good example of how this can work to measure that distance. So all you have to do is put in some numbers in here until you get one where this gray line goes right through. And then there's even another option here, which is if we go to this, this is the British Geological Survey, and they have their own website here where you can get the approximate predicted arrival times of key phases. That would be things like P waves and S waves, the seismic waves of an earthquake. And they have some earthquakes here as well. So let's say we picked that one right there. And then you can pick our station. So you go to under network, it's IRI, because we are in the IRIS Seismographs in Schools program. And then the station name on this particular network is RCMN, and you see it says Rochester Community and Technical College, and we click go, and then let's see what happens here. It should pull up a nice little thing here which shows the great circle or at least the portion of it. And then it tells us here the magnitude, latitude, longitude, depth, location, and so on there. And the distance is, I guess it's not working right now. But when it works, this is pretty good. So the distance to the earthquake there, it says, sorry, was an error. So maybe it's not working so great. But sometimes, if it works, this is actually a good thing as well. All right, so thank you very much, and I hope you'll be able to answer the questions based on this video.